We are going to be estimating and solving exponential equations. This is a two-part note. We're going to be doing part 1 on page 52 in your handy dandy notebook. On page 52, you're going to divide it into quarters. Okay? Easy peasy, easy enough. All right. So this is 2B.2 estimating and solving exponentials, part 1 is what we're doing. All right, I will tell you when to write, but right now you're not writing it. Is that cool? Okay. So to start off here, it says, in the past, we've learned how to solve linear quadratics problems, equations, using basic operations, right? Adding, subtracting, multiplying, dividing. However, did anyone notice when you did your 2B.1 assignment that number 6, you didn't know how to undo? Did you make up something? Did you figure, you thought about it? I love reading how you guys decide to do number 6. It's based on effort, so don't be like, oh, I got it wrong. It's okay. We're going to talk about it. But what we're going to be learning today is how to undo it, okay? That undoing process is called finding the log. So what we're going to do is we're going to take notes on that. So to solve by estimation, still not ready, you will need to find two values of x, okay? The power that will create a range for the value. So essentially, we're looking for a range of solutions, okay? This is before you know how to actually solve. Like, what are my options? How can I guesstimate my situation? Okay. So that's what we're going to be talking about is estimating. All right. Note that in order to estimate, you have to make sure that the exponential is by itself. So before we dive in, keep that in mind. Exponential has to be by itself. All right. In your first box, we're going to write down problem number 6 from your assignment, including the table that you see. Okay, the table doesn't have to be exact and it doesn't have to include the lines. You just need a table of space. Yes. Example in your first box is example 1, problem number 6, which is the one that you did in your for your assignment. And please make sure if you did not turn in your assignment that you turn it in. It was the one you're supposed to do on paper. It was 6 problems. Okay. So you should all have written down the problem. And for guesstimating, what we're going to do is we're going to decide, we're going to go through the series of x's that could possibly make this equal to 9. So if we have our x's, we have our y's, aka we have our input and we have our output, correct? So if I input this x value, what do I get? All right, so to start off here, I just want to make sure that we all know that we're not going to start with 0 because anything to the 0 power is what? No. 1. Anything to the 0 power is 1. That's our exponent 0 property rule. So we're going to start with 2 to the 1. If I have 2 to the 1, what is the output? So I'm inputting 1, and I'm going to get what? 2. If I input 2, what do I get? 4. If I input 3, what do I get? Nope. No. 2 times 2 times 2 is 8. Am I at 9 yet? No. If I input 4, what do I get? 16. Okay. Remember, exponents is just an example of repeated multiplication, correct? So I'm multiplying by 2s to get from one to the next. Do we see that? Yeah. Okay. All right. Huh? So we're guesstimating. So our solution obviously is between an input of 3 and an input of 4. So we know x is between 3 and 4. And that's because 9 has to lie between these two numbers, right? So 9 is somewhere between those two numbers. So our estimated answer would be that x is greater than 3, but less than 4. Does that make sense? And that's all you would do as your estimate. Make sense? Okay. My estimate is greater than 3, less than 4, but I'm going to note that it is definitely closer to 3. And why would I say that it's closer to 3? Because 3 is 8, and 8 is closer to 9 than 16. How do you feel about estimation? Yeah? All right, so in box 2, you're going to do your own estimation, okay? And then you're going to check with the people around you to see if y'all are in the same range. Do we see how it went? Okay. This is the time that while you're practicing, if you don't understand, you talk to me because I cannot read mine. All right. No, here's yours. So in box 2, you have 3 to the x equals 26. All right, here we go. So we have 3 to the x equals 26. Again, is there any point of us starting with 0? No. Why is there no point? It's going to always be 1. Okay. All right. So we have 3 to the 1. And the reason why I say start there is because if all else fails, remember, exponent is just repeated multiplication. So if you forget, you're just multiplying by that same value of 1, right? So 3 to the 2 is 3 times 3, which is 9. 3 to the 3, which is 9 times 3, which is 27. Okay, starting with 1 helps you remember that multiplication is just, powers are just repeated multiplication. Multiplication is just repeated addition. Okay, they all come together. It's a big old family. All right, and I could stop. Did I need to keep going? No, I did not need to keep going. And that's because 2, 3 is where my x lies. And why is it there? Because somewhere in here is 26, right? All right, so we have x is greater than 2, but less than 3. That would be our estimated solution. Make sense? Okay, but it would be closer to 3. So making note that it's going to be closer to 3 because 26 is closer to 27. Make sense? All right, third box. So in our third box, we have 2 to the x plus 1 equals 30. Okay, what did we make note of? When I first heard you keep this in mind, this only works if what? Nobody? Nobody remember? Keep note that this only works if the exponential is by itself. Okay, this has to be isolated. And if it's not isolated, then you need to isolate it. Okay, so what would I need to do to get 2x plus 1 equal to 30 where it's by itself? Inverse operations. Subtract 1. So we're actually looking at 2 to the x equals 29. Make sense? And now it's the same process, correct? The only difference was I had to make sure it was isolated in order to be able to repeat that process. So I have 2 squared. I'm going to just jump in at 4. 2 to the 3 is 8. 2 to the 4 is not 32. You see nothing. You see nothing. 16. 2 to the 5 is 32. Do I need to keep going? No. Where do I stop at? 4 into 5. So we know x is greater than 4, but less than 5. And we know it's going to be closer to 5 because 29 is closer to 32. All right. So that little 2-step that we had to do, was it that bad? No. All right. In box 4 is your example 4. So you're going to create your own 2-step problem, but you cannot use 2 or 3 as your base. Okay. So you're creating your own problem, but you can't use 2 or 3 as your base. Go. So you should have checked your peers from your problem swap. If they did it incorrect, then you're going to fix it. And then you can kindly tell them what they did wrong. The beauty of a problem swap is that one, if you can create a problem and you can check the problem, that means you understand what we did. Does that make sense? Okay. So a sample one that I would have done, I would have done 4x. That's not the x is in the wrong spot. Undo. 4 baby x minus 2 equals 100. Right? That's pretty straightforward. And this is, I have to get 4x. I'm going to have to add 2 equals 102. I would have made you work a little bit. I would have made you multiply just a little bit more than you guys. You guys were nice for the most part. No one had to multiply too much. But you'd have to keep going until you got to 102 or close to 102, right? And so essentially, as long as you understand that's the estimating, then we're golden. How do we feel about part 1? Beautiful, doable. All right, perfect. All right, moving on to part 2. Next page, please.